All right, everybody, welcome back. We're going to be on page 19 of your student journal, which is in section 1.4 about area and perimeter. So we're going to start talking about polygons. So a little bit of vocab here to start. A polygon it stands for like many-sided figure. Okay, the deal is though, for the sides of a polygon, you have to have like line segments. We're going to see some examples here in a second. So you'd have to have the line segments. So there are no curved edges on a polygon. A side is just one of the edges, a vertex. We're going to look at the picture here. Engon is naming. Convex and concave. We'll look at those as some examples. I think it's easier to kind of see what they look like. And depending on the class you're in, you may have already done the interactive vocab for that. So let's look at some polygons. So a figure that lies in a plane is called a plane figure. A polygon is a closed plane figure. So what does it mean by closed? Closed just means like a polygon can't be this. It can't be a polygon. It's not closed. It's open on one side. So this would be open. So that is not a polygon. And again, the prefix poly means many, so many sides. So figure formed by 3 or more line segments is they're called sides. You need 3 or more because if you only have 2, you can't close it. So you got to have 3 or more. 3 would be a triangle, right? And each where 2 sides meet, these are called vertices. That's the plural. So this is called a vertex. Plural of vertex is vertices, that's the plural. Okay, plural, vertices, V-E-R-T-I-C-E-S. That's the plural form. And this is like a polygon, right? This polygon, you name the polygon based on its vertices. So it's named on the vertices, name the polygon. Generally in the order that they go around that polygon. So this could either be named A, B, C, D, E, going counterclockwise, or I'm sorry, going clockwise, or it would also be okay to name this. You can name it A and go the other direction, E, D, C, B, but you always follow the order of the vertices as you go around. So this is one way, and then you could go the other way if you want. And you could start at any vertex, but we always name polygons based on their vertices and in order. Types of polygons, some that you kind of need to know, but some are more familiar than others. So generally, we call a polygon an n-gon. N is the number of sides. So for example, over here in general, a 7-gon is a polygon with 7 sides. An 8-gon is a polygon with 8 sides. An 82-gon is a polygon with 82 sides. And a 13-gon is a polygon with 13 sides. So we can always name any shape, or I'm sorry, any polygon like this, but some have special names. For example, like for 3 sides, which is N3, we can either call it a 3-gon, or you could call it, as a triangle. A 4-gon is a quadrilateral. A 5-gon, you've probably heard of pentagons before. A 6-gon, it's called a hexagon. A 7-gon, it's called a heptagon. An 8-gon is called an octagon. And then we have 9. A 9-gon is called a nonagon. A 10-gon is called a decagon, and a 12-gon is called a dodecagon. These are the most commonly used names, so I have them on here. Otherwise, generally speaking, most people just name them based on how many sides there are. So if you ever forget these terms down here or something, you can just name a polygon based on how many sides it is. So like a triangle could also be called a 3-gon if you wanted to, okay? So that's just a little bit about naming. Okay, so let's do a little extra practice here. Let's use some vocab. Okay, so classify by polygon by the number of sides and tell whether it's convex or concave. So first of all, how many sides does this have? 1, 2, 3, 4, 5. So we can either call this a 5-gon or pentagon. Pentagon is definitely preferred, but you could call it 5-gon or pentagon. Okay, this is concave. And the reason it's concave is because of this right here. It looks like a cave, right? It goes in. So this kind of goes inside this little concave area. It's kind of collapsed in. So this is going to make this concave, like a cave would be at the side of a mountain or something. So that's concave. How many sides we got here? We got, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is an 8-gon, aka octagon. Octagon. This is convex. There are no caves or like any places where it dips in. So we call this convex. So it comes out, kind of like it just pushes out in all directions. It doesn't cave in anywhere. So this is concave. It has a cave in it. This is convex. And I think for good practice, you should count the number of sides and try to name it. Find the perimeter and area of the polygon with the given vertices. So we need to give ourselves a, we're going to do number 6 here as a practice problem. So we're going to do number 6. So you give yourself a grid or some axes so you know where 0, 0 is. So let's take a look. I'm going to put it right, that's not great line. So I'm going to make this my y-axis. I'm going to make that my x-axis. Okay, so let's plot these points. So where's P? 1, 3. So this is 0, 0. So 1, 3 would be here. So that's P. Q is 1, 1. So 1, 1 is here. R is negative 4, 2. So negative 4 is 1, 2, 3, 4, 1, 2. So over there, there's R. So we have just drawn, now for a triangle, we have a symbol that's triangle P, I should label that, P, Q, R. So we've just made our triangle, right? And so if I connect those, there is your triangle. It's not a right triangle or anything, but let's try to find the area and the perimeter, right? Okay, so let's start with perimeter. What are some things you notice about this triangle? Okay, first of all, if we're looking for perimeter, we see that this side PQ is 2 units. That's pretty easy to count, but the other 2 sides don't seem to be countable, right? We can't just count the blocks. So we have to use something like the Pythagorean theorem or the distance formula. I personally like the Pythagorean theorem. Some of you like the distance formula, so use the distance formula, but I'm gonna do the Pythagorean theorem on here. And let's see, let's draw those triangles to do the Pythagorean theorem for RQ. So I would have a triangle that comes down here and then over. Now we'd need to find this other side, the hypotenuse. So let's count. That's 1 block. That's 1, 2, 3, 4. That's 5. What would the other one look like? I would start, use a different color, use gold. Go from R to P, and back down here. So that's 1 unit, and that's 1, 2, 3, 4, 5. Oh, that's 5 again. Okay, so these triangles are the same size. They're right triangles. So that means these 2 segments here, RP and RQ, are going to be the same length. So we only have to do this 1 time. So let's do the purple triangle. Let's do the purple triangle. So I have a little triangle off to the side here. Let's use the Pythagorean theorem. So here's 5. Here's 1. This is a right triangle. Pythagorean theorem says I need to find this side, which is C in the formula. So A squared plus B squared equals C squared. A could be 1 and B could be, that could be A and this could be B. So this would be 1 squared plus 5 squared is C squared. So that's 1 squared, 1 squared is 1, 5 squared is 25. So 1 plus 25 is squared. So this is 26. So C squared is 26, which means the square root of that, take the square root, and you get C, or that distance, is whatever the square root of 26 is. So approximately, if I grab a calculator, the square root of 26 is 5.1. So it's like 5.1 units. Okay, so that means this segment in here, RP, I'm gonna write it in blue. This is 5.1, and so is the other one, is 5.1. So in total, the perimeter is just add all the sides together. So it's 2 plus 5.1 plus 5.1. 5.1. And in total, that would be, let's see, 10.2 plus 12, 12.2 units. Okay? So that is finding our perimeter. Okay, so now let's look at how can we figure out the area, right? So let's take a look here, and we can actually do a little bit with the area. I'm going to kind of spill over to this grid maybe to help us with the area for this one. So I'm going to use 5 as an extension of, let's do the area over here. So it's not as, doesn't get all nasty together here. So let's do the area. So Q is here, P was here. So area is the space, right? The space contained inside of your figure. Okay, so what we want to know is we want to know this area in here. That is our area we're trying to find. How many blocks is that? Okay, now, if you don't know how to find the area of a triangle, no big deal. We're going to learn a little bit about that. We'll talk about that at the end here. But you do know, from what I see in class, you do know how to find the area of a rectangle, which is like the length times the width. So what I want you to kind of think here is visualize. If you take this triangle and you split it in half, and we just talked about this over here, this triangle that I see on the top that I'm going to kind of shade in, let's go with purple for the top, this triangle up here, and then I'll go gold for the bottom. These two triangles that I have are shaded. They're same size. They're exactly the same triangle, just one's flipped upside down. So if you take one of them and if you take both and put them together, like if I take this triangle in yellow and I draw it, redraw it back up here, right alongside of the triangle that I already had, the top, you are going to get this little rectangle up here. I'm going to try to draw that in maybe color it in black. You'll get this rectangle right here. So if you just take the one triangle and put it next to the other one, you're going to get this rectangle. And you're going to, if I color that in, that is going to be the equivalent space or area of just the original triangle. So how do you find the area of that black rectangle? The area of that rectangle, this thing, let's see, it's 1 unit on the side and it's 5 units on the top. The area is 1 times 5. So this whole thing is 5 square units, or units squared. So the area of the triangle is the same as this rectangle. So that would be 5 square units. Okay, so that's how you can find the area of that shape. So for right now, we're going to try to build rectangles out of our shapes. So if you could try to do that with some of these other ones, it'd be good practice. And then we'll learn a little bit more about the area as we continue.